Alright, we are on our last video for this week. First we're going to start off by looking at the vertex form. Remember, we just learned about the vertex form. Y equals a times this amount x minus h squared plus k. From the standard form, so our ax squared plus bx plus c, we can find the vertex, axis of symmetry, and the y-intercept. Now we can find all of those from the vertex form too. So for example, if we are looking at this vertex form, to find the vertex, remember it's the opposite of this one and the exact of this one. So our vertex would be at 4, -7. You always use your h and your k. It's minus h plus k, so 4 and 7. Sorry, -7. Remember, the axis of symmetry is always the x value of your vertex, so we would have x equals 4. Now, again, if you want to write it down, you would call it x equals h is the way to always find it. Your h value was 4, so x equals 4. To find your y-intercept, remember that your y-intercept is always just where x is 0. So you can just plug in x is 0 into this equation. So if I plugged in 0, 0 minus 4 is being squared, and then we subtract 7. Well, 0 minus 4 is -4. -4 squared is 16. 16 minus 7 is 9. So we have a y-intercept at 9. So here's our vertex, our axis of symmetry, and our y-intercept. Same as we could find with a standard form. So how would we graph this then? Okay, again, if we know our vertex is at 4, -7, we go to 4 and then down 7. We know that our y-intercept is going to be at 9. So right here. So this is not linear, it should not be a straight line, but with nothing in front of here, our a is kind of like 1. So we use our a equals 1 reference. Remember, from the vertex, with an a equals 1 reference, it goes over 1, up 1, here and here. Over 2, up 4. Oops, I go 1, 2, 3, 4. Here and here. Again, starting at the vertex, over 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here and here. And if we went over 4, we'd go up 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, here and here. Perfect. So we used our a equals 1 reference, and it actually fit exactly through our y-intercept. So this would be our parabola. This fits exactly what we needed. Come to this point, come back up, and there's our parabola. Same thing if we wanted to try it without a equaling 1. So we just start from our vertex. If we have y equals 2 times the amount x plus 3 squared, and then subtract 5, we do the opposite of this one, so -3. We do exact this one, -5. So our vertex is at -3, -5. -3, -5. Our y-intercept, we have to plug in 0 for. So 0 plus 3 is 3, squared is 9, 9 times 2 is 18, minus 5 is 13. So our y-intercept is here at 13. Now, this is no longer 1, this is a equals 2, so I use an a equals 2 reference. Instead of over 1 up 1, it's over 1 up 2, here and here. Instead of over 2 up 4, it's over 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8, here and here. Instead of over 3 up 9, it's over 3 up 18. So here and here. So now I have my points plotted out. I just connect them to make my parabola. So we can graph from this vertex form by finding the vertex and then using our reference of 2 to figure out from the vertex how far over and up do we go. Let's do one more. We have 1/2 of x minus 2 squared plus 1. So we start at our vertex of opposite of this is 2, exact of this is 1, so 2, 1 is our vertex. Plug in 0 right here. 0 minus 2 is negative 2. Negative 2 squared is 4. Half of 4 is 2, plus 1 is 3. So our y-intercept is at 3 right here. We're going to use our reference of 1/2. So remember, a 1/2 reference means instead of going over 1 up 1, it's over 1 up a half. So just right there. Instead of over 2 up 4, it's only over 2 up 2. So here and here. Instead of over 3 up 9, we only go half of that. Over 3 up 1, 2, 3, 4 and a half. There and there. And let's do one more. Instead of over 4 up 16, it's only over 4 up 8. 1, 2, 3, 4, 5, 6, 7, and 8. So here are the dots plotted out for our parabola. Now what happens if our a value is negative? Really all that does is make our parabola go downwards. So we still use our same reference, we still use our same vertex, we just point everything down instead of going up. So looking at this vertex form, remember our vertex is at the opposite of this one and the exact of this one. So over at 3, 4. Here is my vertex. Plugging in 0, I get negative 3 squared is 9, 2/3 of 9 is 6, but negative 2/3 of 9 is negative 6, plus 4 is negative 2. So here is my y-intercept. Now I'm going to use my 1/2 reference, but because this is negative, I'm going down. So instead of over 1 up 1, I'm going over 1 down a half. Here and here. Instead of over 2 up 4, I want half of that over 2 up 2, but it's actually going down. So down 2. And instead of going over 3, oops, I was using half. These are all thirds. I'm going to change that a little bit. Over 1, down 2/3. Over 2, down 8/3, which is 2 and 2/3. So 1, 2, a little bit more. Over 3, instead of up 9, we want 2/3 of that, so down 6. So down 1, 2, 3, 4, 5, and 6. And you can see my y-intercept also goes through that. So, sorry, this should not be a 1/2 reference. This should have been my 2/3 reference because of this. There we go. So that's how we would figure out our parabola with that negative a value. Now what if we're using a standard form and our a is also not negative? Well, again, we're pretty much doing the same thing. You can, if you want to, change this into vertex form. We can do a completing the square to figure it out in vertex form, or we can say, all right, let's just find the vertex by using negative b over 2a. Negative 2 over, what's 2 times negative 1/4? It'd be negative 2/4 or negative 1/2. Now instead of dividing by a fraction, you can multiply by its reciprocal. So negative 2 times negative 2 comes out to a positive 4. So 4 is our x value. We just plug in 4 everywhere we see x here. 4 squared is 16. Negative 1/4 of that is negative 4. 2 times 4 is 8. So negative 4 plus 8 is 4. Minus 3 is 1. We have a vertex at 4, 1. My y-intercept, I'm plugging in x is 0. So this term goes away, this term goes away, and we're at negative 3. So 0, negative 3. I'm using my reference of a equals a fourth. So instead of going over 1 up 1, I'm going over 1 down a fourth. Again, I'm going down because this is negative. Instead of going over 2 up 4, I'm going over 2 down 1. Always just a fourth of it. Instead of over 3 up 9, I'm going over 3 down 9/4, which is 2 1/4. So 1, 2, and a little bit more. And instead of over 4 up 16, I'm going over 4 down 4. So these are the points plotted out for my parabola. Again, I just used the a equals 1/4 reference. So, lastly, let's look at how to complete the square if our a value is not 1. Now, warning, this example is going to get kind of difficult. Even though these look like nice, easy numbers, I used kind of a more difficult one because I want you to be able to see what's going on throughout, or what it might be like to use a more difficult problem. Now, the steps are going to be exactly the same, except for something added before and added at the end. So here were the steps that we used before. All we're doing is dividing by a at the beginning and then multiplying by a at the end. So all of those steps, I'm going to put those aside, and we're going to look at what we do here. First step, divide both sides by a. Our a value is 2, so we need to get rid of that 2. So this side is divided by 2. All three of these terms are divided by 2. That way, this is now just a regular x squared. Remember, in the visual, I can make a square out of an x by x. So, now that we have this piece just as an x squared, I go through all of the same steps. Subtract the constant. So I move this 9/2 over to this side. Now, we keep on going. Do half of b squared, and you add that to both sides. Now, this b value is 5/2. Half of that would be 5/4. Square that would be 25/16. So I'm adding 25/16 to both sides. Now I'm turning my x side into x plus b/2 times another x plus b/2. So I turned all of this into x plus 5/4, x plus 5/4. Notice this is the same 5/4 that I used to get this 25/16. Now, instead of calling this two binomials, I'm just going to put them together into x plus 5/4 squared. Notice on the left side, I was also changing these pieces. So instead of 9/2, I just multiplied the top and bottom by 8 and called it 72/16. The reason I did that is because this one was in 16ths. Now I can combine them and call it -47/16. So I still need to get this constant back to this side. Add it back over. We have y/2 equals x plus 5/4 squared minus 47/16. And we want the y alone. So I just multiply both sides by a. So multiply by 2, multiply by 2, multiply by 2. This becomes y. This has a 2 in front of it. Otherwise, it's the same binomial squared. And this got multiplied by 2, which remember is the same as doing times 2/1. The 2 and the 16 cancel out. 8 and 1. And so it's now just 47/8. So this would be my end result. Now, you would not be expected to graph this with all of these fractions, but I wanted to walk you through the steps. This is how you would do a completing the square if you had an a value that was not 1. So again, write these down and remember them. Divide both sides by a. Subtract the constant. Add b squared, half of b squared to both sides. Turn the x side into x plus b/2 and another x plus b/2. Then turn it into x plus b/2 squared. then subtract the constant to get y alone, and multiply both sides by a to get y totally alone. Now let's look at one more thing. Let's go from vertex form into standard form. If you have a vertex form and you want to put it into standard form, all we need to do is expand it out. Essentially, we're just foiling. So we turn this binomial into two binomials, and then we just expand it out. X times x is x squared. X times negative 3 here. Negative 3 in x. Negative 3 times negative 3. Now I distribute my 2 to each piece. Oh, actually, I think we combined it first. Negative 3x made negative 6x. Now I distribute 2 times each one of these and combine my two constants. So we can go from our vertex form into a standard form, just like we can go from a standard form, go through our completing the square, and get it into a vertex form. We can go either direction. Either way will work. So that'll cover it for our last video then. We went over using the vertex form. We talked a little bit about graphs. We know how to use negative a values. We tried completing the square when a wasn't equal to 1. And we went from vertex form into standard form.